Hello everyone, in this theoretical tutorial number 26 we will review the diode rectification due to the diode strong nonlinearity, and we will compare with the RC high-pass filter. We will start with a refresh of the characteristic and key points of the RC high-pass filter. At the cutoff frequency f in blue, the sum of vector Vout plus Vc equal Vin as shown, with Vout phase of minus 45 degrees compared to Vin. If we double the cutoff frequency f at 2f in pink, we will increase the gain Vout over Vin of plus 2 dB with a Vout phase of minus 27 degrees compared to Vin visible on the vector diagram. Now if we divide the cutoff frequency f by 2 at f over 2 in green, we will cross minus 7 dB with a Vout phase of minus 63 degrees compared to Vin visible on the vector diagram. So the drop is minus 4 dB if f is divided by 2 and plus 2 dB if f is multiplied by 2, compared to the minus 3 dB at the cutoff frequency f. The difference between asymptote and the curve Vi over Vout is plus 1 dB at 2f and f over 2. At the cutoff frequency f, the difference between asymptote and the curve Vin over Vout is minus 3 dB. All the vectors Vout and Vc have a right angle of 90 degrees, and this angle follows the half circle from Vin equal 0 at low frequency to Vin equal 1 at high frequency. In the time domain, we have a Vin sinusoidal signal at the frequency equal to 1 over t, with an amplitude of 2 volt and a DC value of 4 volt. As 1 over t is much greater than the cutoff frequency f, the gain is 1, and the amplitude of the voltage Vout equals the amplitude of the input voltage, 2 volt. But the 4 volt DC voltage of the Vin is transformed to 0 volt on the output voltage due to an infinite attenuation, so 4 volt gives 0 volt. By a quick simplification, it looks like the DC voltage does not go through the capacitor C. But the capacitor rule is the average current IAV in a capacitor is 0, and the zero average current in a linear element as the resistor gives an average voltage of 0 volt. In the I versus V characteristic, with the capacitor rule average current equals 0, it is easy to visualize that a zero average current gives an average voltage equal to 0. But the same capacitor rule of zero average current in a strong nonlinear element gives a very specific current with high and short peak due to the conducting diode, and a long, very low current value due to the current leakage diode. But as area plus and area minus are equal, the average current is equal to 0. But this zero average current in this nonlinear element has an average voltage different of 0. Now we do a comparison between both schematics, the RC high-pass filter on top and the same schematic where the linear resistor is replaced by a diode, bottom schematic. On the RC high-pass filter, the input DC voltage does not pass on the output voltage. But in the bottom schematic, it is the opposite. The input voltage has a 0 DC voltage, but the rectifying diode provides an average positive voltage across the diode in reverse biased. Of course, the rectification effect forces the output voltage to does not exceed the value of minus Vd. I want to thank you for your attention. On my next theoretical tutorial number 27, we will start a new sequence dedicated to the electricity discovery. So see you soon and stay tuned.